today our topic of discussion is basically chemical bonding. So these will be our lesson objectives. We will be covering chemical bonding, types of bonding, ionic bonding, covalent bonding, metallic bonding. Along with, we will be doing some past papers questions. So what do you mean by chemical bonding? It is the force of attraction that binds atoms together, okay, is called chemical bonding. So the force of attraction that is basically developed between atoms, between one or more atoms, you can say. So this is basically the force of attraction, and that is basically called as chemical bonding. And this force of attraction can be developed either by transfer of electrons, or it can be developed by sharing of electrons. As we know, it is basically done in covalent bond. So there are basically three types of chemical bonding. The one is ionic bonding, that is basically occur between a metal and non-metal. And this covalent bonding is basically occurred between two non-metals by sharing of electrons. This is metallic bonding that basically occurs in metals. Okay, so let's move further. So this is ionic bonding. Ionic bonding, a bond formed by transfer of electron from metal to a non-metal, so as to have an electrostatic force of attraction between cations and anions. First of all, I just want to elaborate one thing, why atoms make bond. Why atoms make bond. So atoms actually make bond. So atoms make bond to move from higher energy state to lower energy state. To lower energy state. So what actually is happening? This high energy state respond to the atom whose outermost shell is incomplete. Incomplete outermost shell. Incomplete outermost shell. Okay. And what we mean by lower energy state, that means complete outermost shell. Okay. So high energy state means incomplete outermost shell. Lower energy state means complete outermost shell. So what actually is happening? A bond formed by transfer of electron from metal to a non. Let's take an example of sodium. Sodium is basically Na1123. That means it has 2 electrons in its first shell, 8 electrons in its second shell, and 1 electron in its last shell. Chlorine is basically 17, can say 37. So it has 2 electrons in its first shell, 8 electrons in its second shell, and 7 electrons in its last shell. So what we need to do here, outermost electron from sodium is basically transferred to chlorine. In this way, what will happen? What will happen? Outermost electron from sodium is transferred to the outermost shell of chlorine. In this way, now sodium's outermost shell would be having 8 electrons. If this electron is basically transferred to here, and now chlorine would be having 8 electrons in its outermost shell. So chlorine has gained 1 electron and sodium has lost 1 electron. So the electron which is you can say donated by sodium, that is basically transferred to chlorine. In this way, sodium is become a cation which is having a positive charge on it. Okay, so it is having a positive charge, and chlorine is having a negative charge. You can see here. Now, sodium has become a cation. The one which lose electron, that has become a cation. Okay, so it has become a cation. And the one which gains electron, as we know, chlorine has gained this electron from sodium. So it has become an anion. And now there is electrostatic force of attraction that is basically developed between a cation and an anion. So this is basically anion. So this electrostatic force of attraction basically holds cation and anion together. Okay. So let's move further. Like for example, you can see this example as well, magnesium chloride, in which magnesium is basically Mg1224. So it has 2 electrons in its outermost shell, so it has to lose 2 electrons. While we know that chlorine is having 287. Now, chlorine can only accept 1 electron, but magnesium has to lose 2 electrons to complete its outermost shell. So what it is going to do, it is going to lose 2 electron, which is gained by 2 chlorine atoms. Okay. So 2 chlorine atoms would be like this. So now what happened? 1 electron would be transferred here, 1 electron would be transferred here. That you can see here, that 1 electron is transferred to this chlorine and 1 electron is transferred to this chlorine. In this way, as magnesium is basically losing 2 electrons, so it has got a +2 charge, and now it has become a cation. It has become a cation. And now chlorine has gained 1 electron, so it has become an anion. And this chlorine has also gained 1 electron, so it has also become an anion like this. So the formula, how does this formula actually become? We know Mg is having +2 charge, while chlorine is having negative charge. So it would go here, it would go here, and the formula would become MgCl2. Okay. Now, let's discuss about the structure of ionic compound. Ionic compound structure are like this. We call this kind of structure as giant lattice structure. Why we call them as giant lattice structure? Because ions are arranged here, you can say, in an orderly manner. So ions are arranged in an orderly manner. And over here, you will be seeing that each chloride ions is surrounded by 4 sodium ions, and each sodium ion is surrounded by 4 chloride ions. Okay, you can see here that each sodium ion is basically surrounded by like 1, 2, 3, 4 chloride ions. Okay, in the same way, chloride ions are also surrounded by 4 sodium ions. Like this is sodium ion, 1, 2, 3, and the one is here, which is 4. Okay, and this structure basically grows in 3 dimensions. That is why we are calling this structure to be giant lattice structure. a joint lattice structure. As we know, like their formula could become Na4Cl4 because we know each chlorine is surrounded by 4 sodium ion and each sodium ion is surrounded by 4 chlorine ions. So they would be cancelled out and the formula would become NaCl. So let's move further. Now we are going to discuss about properties of ionic compound. The major factor is that they would be having high melting point and high boiling, okay, with low volatility because they have high melting point and boiling point, and that is why they would be having low volatility. What do you mean by volatility? Volatility is the ability of liquid to be changed into gaseous state. This concept is quite clear that if like if you have filled the petrol in your pipe, then what happens if you will open the you can say cap from it, then all the petrol will be vanished. Where does that petrol go? That petrol is basically changed into vapor state. Okay, because why it is basically changing into vapor state? Because petrol is quite volatile, high volatile. That is why it is basically changing directly into vapor state. So this is basically cation and anion, they having strong electrostatic force of attraction. That is why they would be having high melting and boiling point. And this question is oftenly asked in the exam, that why ionic compounds are having high melting and boiling point, are having high melting point and boiling point. So the reason is quite simple, that cations and anions would be having strong electrostatic force of attraction. I'm not going to write the answer. It's quite simple now. So let's move further. Ionic compounds can conduct electricity in aqueous form or in molten form. What we mean by molten form means in melted form. Okay. Either ionic compound can conduct electricity in aqueous form. Aqueous form means when they are dissolved in water. When they are dissolved in water. So only in this way they would be able to conduct electricity, because in aqueous form they would be having free moving ions. Okay, like this is NaCl, this is in solid state, and when we are putting it in water, then what happens? It would be converted into ions like this, ions like this. So this is basically aqueous form, and they would be split up into cations and anions. So that is why they would be able to conduct electricity. Like you can see here that sodium and chlorine, they can move freely. Okay, because of free moving ions, they would be able to conduct electricity. Now, they are soluble in water and insoluble in organic solvent. The reason is quite simple, because NaCl, this is basically positively charged, and Na in water, as you can see, water here, this is oxygen, this is hydrogen, this is hydrogen. So we know that hydrogen is basically having a partial positive charge, and this one would be having partial negative charge. So oxygen, you can see this represents oxygen. Okay, so oxygen is basically attracted with this cation, and these are basically hydrogens which are attracted with this chloride ion. Okay, slightly positive hydrogen are attracted to chloride ions like this, and slightly negative oxygen here, they are basically attracted to sodium ions, and that is why we can say that most of the ionic compounds are soluble in water and they are insoluble in organic solvents, because in organic solvents there is no water. So in fact, cations and anions are unable to develop any force of attraction. So this is basically the reasons why they are soluble in water, because of the force of attraction that is developed between water and cations and anions. So let's move further towards some past paper questions. Suggest one other physical properties of magnesium bromide. We know magnesium bromide, this is magnesium bromide, and that is basically an ionic compound. So its physical property would be that it is having high melting point and boiling point. Okay. So explain why calcium bromide conduct electricity when molten but not when solid. So they can conduct electricity when molten because of free moving ions that we have already discussed. But in solid, there is no free moving ion. Free moving ion. Predict two other physical properties of calcium bromide. It could be that it can conduct electricity in aqueous form, or you can say has high melting and boiling point. And we can also say that they are most of the ionic compound, including this calcium bromide, they are soluble in water. They are soluble in water. So these are the properties that you must need to memorize. So let's move further. Magnesium reacts with bromine to form magnesium bromide. Magnesium bromide is an ionic solid at room temperature. Explain in terms of movement of electrons how magnesium bromide is formed by the reaction of magnesium with bromine. We know that magnesium is basically 1224. It is basically 282. And bromine is having 7 electrons in its outermost shell. Okay, I'm just telling you about the outermost shell. So what is going to happen? 2 electron from magnesium, 2 electron from outermost shell, most shell of magnesium will be transferred, will be, they have 7 electrons in outermost shell. So, I'm sorry, I have drawn it wrong. So it's 282. Okay. So these 2 electrons will be transferred to bromine. One will be transferred to this bromine, which is having 7 electrons in outermost shell, and 1 electron would be transferred to this bromine, which is also having 7 electrons in its outermost shell. So what will happen to electron from outermost shell of magnesium will be transferred to two bromine atoms. Two bromine atoms. Okay. In this way, magnesium would be having +2 charge and bromine would be having minus charge. And there will be two bromine. Okay. So in fact, the final formula we know that would become MgBr2. Now, this is a MCQs. The table contains information about 4 substances. Which substance is an ionic compound? So ionic compound, first of all, the most of the ionic compound, they are solid. So option, we know that option 1A becomes incorrect. First of all, they can conduct electricity at room temperature? No, they cannot conduct electricity at room temperature. So only this option seems to be right. Let's discuss about some more. They can conduct electricity when molten. I have told you molten form is basically the melted form. And they can conduct electricity when aqueous solution. Yes. So this is also right. So D is basically the right answer. Now, let's move further towards covalent bonding. If we discuss about covalent bonding, I have already told you they are formed by sharing of electrons between non-metals. Like for example, hydrogen is having one electron, only one electron, okay? So it combines with another hydrogen and they are going to share electrons like this. In this way, outermost shell of hydrogen, which is basically a duplet. Okay. What is duplet? Duplet is the one shell which is having two electrons. Okay. And what we mean by octet? Octet is the outermost shell which is having 8 electrons. So this is hydrogen and they are basically sharing their electrons like this. So this is basically forming a single covalent bond as they are sharing one pair of electrons. So this is basically one pair of electrons. These are two pair of electrons. These are three pair of electrons. Okay. So now let's move further towards oxygen. Oxygen is basically O816. So it has 6 electrons in its outermost shell. You can see 6 electrons. So it needs to complete, it needs 2 electrons to complete its outermost shell, which is basically a octet. So it is going to make a bond with another oxygen and they would be sharing 2 pair of electrons and that basically forms a double covalent bond. So because it is sharing 2 pair of electrons. Now nitrogen is N7, that is 14. So it has 5 electrons in its outermost shell. So it needs to complete 3 more electrons. So it is going to make a bond with another nitrogen, which would be sharing 3 pair of electrons. 3 pair of electrons like this. And that is why we would say that they are basically forming a triple covalent bond. Okay. So let's move further towards a compound which is basically named as methane. This is methane gas. And we are using methane gas at our home for cooking purpose. And we know that this is basically carbon and this is hydrogen. Carbon is C612, so it has 4 electrons in its outermost shell. So what is happening around here? Carbon is basically making 4 single covalent bonds. Why single covalent bond? Because they are sharing 1 pair of electron. So it is basically forming single
Sir,
covalent bond. Yes, yeah.
I'm
Wait,
gonna have
please.
another class now.
So So it is basically sharing a single covalent bond, as you can see. So the formula, that is why now hydrogen is basically fulfilled its duplet. And in this way, carbon has also having 8 electrons right now. So let's move further towards the example of water. It's basically H2O. Oxygen has 6 electrons outermost shell. So it is going to make 2 single bonds with hydrogen. They are basically sharing their hydrogens like this. And these 2 pair of electrons, they basically exist as lone pair of electrons. So they exist as lone pair of electrons. So let's move further and let's discuss about properties of covalent compound, which is having simple molecular structure. So they exist as liquid or gases, and they have low melting point and boiling point because of weak intermolecular force of attraction. So what is basically weak intermolecular force of attraction? For example, this is basically carbon dioxide. Carbon dioxide is CO2. It is basically a molecule, and there is another molecule of carbon dioxide. The force of attraction, this is basically a force of attraction that basically binds molecule together. This force of attraction is basically called as intermolecular force of attraction. Intermolecular force of attraction. So this intermolecular force of attraction is basically weak in this simple molecular structure. So this, because of this weak intermolecular force of attraction, covalent compounds would be having low melting point and boiling point. I can show the structure of water as well. No, water is not the one, like the oxygen molecule. This is oxygen molecule. This is oxygen molecule. So the force of attraction that binds molecule together, this is basically weak. That is why it would be having low melting point and boiling point. Although the one, okay, this force is basically also called as van der Waals force. Okay, and the force of attraction that binds oxygen atom together, like we know oxygen basically forms a bond like this, like this. So this bond is basically called as intramolecular force of attraction. Intramolecular force of attraction, and this is basically quite strong. Although this van der Waals force or intermolecular force is weak, but intramolecular force is quite strong. Okay, just keep this difference in your mind. So let's move further, and they do not conduct electricity. Reason is quite simple, because they don't have free moving ions or electrons. They are soluble in or only in organic solvents, but not in water, because there is no certain force of attraction that is basically developed in water. So there are some past paper questions. Phosphorus reacts with chlorine to form phosphorus trichloride. Dot and cross diagram. Phosphorus is basically P1531. So it is having 2, 8, and 5 electrons in its outermost shell. So it needs to complete, you can say, 3 more electrons to complete its outermost shell. So it is going to make 3 bonds with chlorine like this. Okay, like this. So this is basically chlorine having 7 electrons in the outermost shell. Another electrons is with chlorine. So it is having again 7 electrons. So another electron with chlorine, another bond with chlorine having 7 electrons. Now its outermost shell of chlorine is also completed and phosphorus is also completed, but they are 1, 2, 3, 4, 5, 6. So 2 electrons would be present here as lone pair on phosphorus. Okay, they have made a bond with chlorine like this, and they are basically made 3 single covalent bonds with chlorine. So, titanium chloride is a colorless liquid with a low boiling point, suggests the structure and bonding. So, they would be having simple molecular structure, because the covalent bonds which is having low boiling point, they must be having simple molecular structure. Okay, and covalent bond among them. Okay, so let's move further. Explain in terms of structure point, and we have already Okay, explain in terms of structure and bonding why chlorine has a low boiling point and sodium chloride has a high boiling. So, in fact, we know that chlorine, chlorine is having weak intermolecular forces, weak intermolecular forces with simple molecular structure, with simple molecular structure. So that is why we would be saying that it would be having weak intermolecular low boiling. Okay, as it is having weak intermolecular forces with simple molecular structure. So now NaCl is having a giant lattice structure with electrostatic strong electrostatic force of attraction. Force of attraction. So we have already discussed in this video that Cn2 is basically having this intermolecular forces between one molecule and another molecule. So these are intermolecular forces. What are these? Intermolecular force. This is intermolecular force. So that is basically weak. On the other hand, this is cation, sodium cation, and this is chloride, this is anion. So they are having this force of attraction, which we call as electrostatic force of attraction. So that is strong. Okay. So let's move further. Now, this is metallic bonding. What we mean by metallic bonding is a strong electrostatic force of attraction between cation, this is cation, and C of delocalized electron. Why we are calling it as delocalized electron? Because they are freely moving. They are freely moving. That is why we call them as delocalized electron. First of all, we know metal they belongs from either group 1, either group 2, or either group 3. So they all would be having 1, 2, and 3 electrons in their valence shell. So what they tends to do, they would tends to lose electrons. So like group 1 metal, they would be losing one electron. Okay, so they would be losing one electron, and group 2 they would be losing two electrons, and group 3 they would be losing three electrons. And we know one thing, that whenever a metal loses electron, so they would be converted into a cation. And we know when non-metal gains electron, they form anion. So this is a cation that is formed here. And how they are formed? By losing electrons. So the electron which are lost by cation, they are surrounded by cations. Okay, they are surrounded by cations and they are freely moving. They are freely moving. So because of that, as they are freely moving, we are calling them as delocalized electrons. So because they are freely moving electron, they would be able to conduct electricity. They would be able to conduct electricity. On the other hand, when we apply force at this point, we apply force at this point, this layer would slide past each other. Okay, this layer would slide past and it would come here as well. So because of this property, we would be saying that metals are malleable and ductile. What we mean by malleable, that by hammering, if we hammer the metal, then by hammering, metal would be converted into thin sheets. Metal would be converted into thin sheets, into thin sheets. And what is basically ductile? That metal can be stretched, can be stretched into thin wires, stretched into thin wires. Okay, so I'm just going to repeat the properties. First of all, that metals are good conductor of electricity. Reason is that they would be having freely moving electron. This is the first property. Okay, and second property is that metals are malleable and ductile. This is second property, and the reason is that when the force is applied, the layers would slide past each other. These layers would slide past here. Okay, so this is basically the second property, and the third property is that metals have high melting point and boiling point. Why? Because of strong electrostatic force of attraction. Strong electrostatic force of attraction that is present between cation and sea of electrons. That is present between cation and sea of electrons. Because of this property, we would be saying that metals would have high melting and boiling point. So I have written some properties here that they can conduct electricity because of delocalized electron. Delocalized electrons, we have already discussed that they are free moving electrons. While on the other hand, metals are malleable. Malleable means that they can be converted into thin sheets, and ductile means that they can be stretched into wires. Why? Because when the force is applied, the layers would slide past each other. That I've already told you. And they would be having high melting and boiling point because of strong electrostatic force of attraction that is present between cation and sea of electrons. So let's discuss some of the past paper questions. State two properties which are characteristics of most metals. So we would be saying that they would have high melting point and boiling point. And the other property we can say that they would be a good conductor of electricity because of free moving electrons. So conductor of electricity because of free moving electrons. So zinc has metallic bonding. So you can see we have to draw this metallic bonding like this. Okay. Now this here.
Yes.
And now we can show the delocalized electron in between them. So these are delocalized electrons that we have to show. So here, how can we describe it? That cations are surrounded by sea of electrons, and there is strong electrostatic force of attraction between cation and sea of electrons, between cation and sea of electrons. Now let's move further. Why zinc is a good conductor of electricity? Because of free moving electrons. Yes, thank you.